Hello math friends, today we're going to talk about how you calculate the slope of a line by using the slope formula. So our slope formula is this right here, where we have y1 minus y2 over x1 minus x2. So in order to calculate the slope of this line, or the rate at which it's going, in this case downhill, we have to use this formula. And to use the formula, we need 2 points. So I have 2 points given on our line, and we just have to remember that when we're dealing with a point, it always x comes first and y comes second. So we could call this point x1 and y1. And then this point over here, we could call x2 and y2. And now really all we have to do to be able to calculate the slope of the line is to fill in our values into our equation. The one thing that oftentimes students get hung up on is that the y's go on the top, but they're actually the second values, so that can sometimes be confusing. So watch that. y1 is a 1 minus y2 over here. y2 is a 0. We're going to put that over x1, which is a negative 2, minus x2, which is a 3. So now if we go ahead and do the subtraction, 1 minus 0 gives me 1. And stop, chop, chop here. Negative 2 plus negative 3 gives me negative 5. So the slope of my line ends up being negative 1/5. I know it should be negative because this is a line that's going down. So using that slope formula to get the slope of the line. In this case, I could also check it since I have the graph. It's a rise of 1 with a run of 1, 2, 3, 4, 5. Sure enough, my slope formula answer matches what my using my graph answer would be as well. All right, if I have another one, this time the points aren't given to me, so I'm going to have to pick them off. And when I pick my points on my graph, I'm going to want to make sure that I pick ones that cross the coordinate lines really good. So I like this point right here looks real good, and this point down here we'll use looks real good. Okay, so this point is going to be negative 1, 3. And this point down here is going to be 1, 2, 3, 4, negative 1, 2, 3, 4, 5. So 4, negative 5. And now I can use those values in my slope formula. So I'm going to go ahead and name them right on my line so that I remember that this is going to be my x1, y1, and down here I'm going to have my x2 and my y2. And now I can just kind of plug them in and work, work, work. y1 is 3 minus y2, which is negative 5, over x1, which is negative 1, minus x2, which is 4. I can stop, chop, chop. 3 plus 5 is 8. Over, stop, chop, chop. Negative 1 plus negative 4 is negative 5. So my slope of my line here is going to be negative 8/5. I just do a check. Yep, it's going downhill. So it should be negative. And it looks like I have a pretty big rise to a pretty big run there. It looks pretty steep, so it should be bigger than 1, and sure enough it is. So the slope of my line using the slope formula, awesome. Pretty rock star. Here we go, let's try one more. Now this time they don't give me the graph, which is totally fine. I can go ahead and calculate it anyway. I can call this x1 and y1, and this x2 and y2. And I don't even need the graph because I have my super duper formula. So I fill it in. y2, or y1 is 6, minus y2, which is 10, over x1, which is negative 9, minus x2, which is negative 12. I might stop, chop, chop here. 6 plus negative 10 gives me negative 4. And I could stop, chop, chop here. Negative 9 plus 12 is going to give me 3. And I have a negative slope. So I can kind of picture my line, and it's bigger than 1. So I can kind of think, ooh, it's a line going downhill, but it's kind of steep. It's bigger than 1, so kind of a steep slope. And that's not obviously an exact graph of it, but it just gives me a vision of what the line might look in my head. And all I can tell you is all this talk about slopes just makes me want to get out there on my skis and go flying down the hill. Woo! Happy slope day!